All right, y'all, we are going to jump into our new unit, which is rational. So today we're going to do an intro to rational functions. And the first thing we're going to do is define rational functions. So go ahead and draw this box on your paper. And I would take up at least half a page with this box, draw a big box. And in the middle, you are going to put rational functions. And we are going to define rational functions very quickly. Okay, so in the left hand, let's start upper left over here in the definition box. So a rational function is a function, and I would write all of this down, a function that can be written as P over Q, where P and Q are polynomials. Polynomials was our last unit, where P and Q are polynomials, and Q is not allowed to equal 0. Okay, so that's the definition of a rational function. So what is this saying? Well, as you can see, P over Q, rational functions are fractions. Fractions made up of functions. Okay, so rational functions are fractions made up of functions. That's a characteristic. And then we said Q is not allowed to equal 0 over here. Well, that's another characteristic. The denominator cannot equal 0. Can't equal 0. Cool. Let's get some examples down. So we're going over to this box over here. Examples. Here's an example of a rational function, x squared minus 4x over x plus 1. It's a fraction. It's made up of two polynomials. We have a polynomial in the numerator, a polynomial in the denominator. Boom. Rational function. All right, here's another example, 2x over 3. Here's another example, 2x plus 1 over 1. So really quick, let's focus on this one. Y'all, anything could be considered a rational because you could put it over 1. Any polynomial could also be considered a rational function. Okay, and then lastly, 3 over 5. Fractions still count. Fractions still count as rational functions. So how about non-examples? Things that are not examples? X plus 1 divided by 0. Well, we said over here the denominator can't equal 0, so that is not a rational. What about 2 to the x over x plus 3? What's wrong with this one? The x is in the exponent. That's not actually a polynomial. Remember, rational functions must be made up of polynomials or like numbers. But 2 to the x, that's actually an exponential function. We'll learn about those later. All right, and then lastly, square root of x over 3x. That's not a rational function. Why? Because square root of x is not a polynomial. Again, that is a radical, and we will talk about those next unit. Okay, now that we have defined rational functions, let's actually do some things with these rational functions. So here we go. First thing we need to talk about is dividing by 0. Why did we say that you are not allowed to, over here, why did we say that we're not allowed to divide by 0? So let's really quick talk about this. I want you to draw this circle on your paper. It's a circle split up into quarters. And then let's call this circle pizza. So we're going to pretend this is pizza. And I want you to figure out how would you represent this fraction 1/4, how would you represent that on this pizza? What would you do to represent that fraction? Okay, so hopefully we said we could shade one out of the 4 slices, right? Shade 1 out of the 4. The 4 is like the whole thing, right? 1 out of the 4. Okay, so really quick, let's talk about what the 1 represents. This represents the number of slices, right? And then let's talk about what the 4 represents. The 4 is out of 4 total possible slices. So this would be, the 4 is also like the number you start with, right? Okay, so now that we've talked about, how do we set up a fraction, let's figure out this next question. So I want you to think about this down here. Now think about this one. How would we represent the fraction 1 over 0 on a pizza? How would you represent the fraction 1 over 0 on a pizza? So now we have this fraction, 1 over 0. What would you say? Okay, so 1 over 0, well, let's break this down again. This would be 1 slice, because that's the number of slices. But over 0, that would mean let's say we start with 0 slices. So could you give your friend a slice of this pizza? Could you give your friend a slice of this pizza that we're talking about, the 1 over 0 pizza? Well, you started with 0 slices. So no, you can't give your friend any slices. That's why we're not allowed to divide by 0. You're starting with nothing. You cannot give something away when you have nothing. So you are not allowed to divide by 0. So I want you to write this down. Write this down. And this is like the important key takeaway. We are never allowed to divide by 0 in math. Okay. And then I remember this. Another teacher showed me this, and I think it's a really good way to remember this. She wrote n divided by 0. Look, it spells no. Get it? N-O. No, not allowed. But are you allowed to have 0 on top? 0 on top is okay. Okay. 0 divided by something, here, let's write that down over here. 0 divided by something equals 0. But when you divide by 0 over here, this one, N-O, divide by 0, you get undefined. So you should know that actually. When you divide by 0, you get undefined. Write down all this stuff in pink. All right, and we're going to move on. All right, explain in your own words. Explain in your own words, why are you not allowed to divide by 0? Go. All right. So hopefully we had some good explanations, and I just wanted to reiterate, no, you're not allowed to divide by 0. That would give us undefined. If you didn't already put that in your notes, make sure you put that in your notes. It is okay to have 0 on top of any number. Pretend the n and the k's, that's a number. It is okay to have 0 on top. You would just get 0. Okay. Domain restrictions. We are not allowed to divide by 0 in math. That's what we just went over. So the x value that makes the denominator equal 0 is restricted or not allowed. So any x value, you need to write this down, x value that makes the denominator equal 0 is not allowed, is restricted. Since the domain is all the x values, you should know this, domain is all the x values. We took notes on that last week. We call this x value a domain restriction, the one that makes the denominator equal 0. All right, so let's get this example problem down. You need to write this down in your notes. Find all the values of x for which the rational function h of x equals x plus 5 over x plus 6 times x minus 3 is undefined. Get this down in your notes. All right, so we're trying to figure out the x values, the values of x, for which this rational function is undefined. All right, really quick, let's remind ourselves. A rational is UND would be a good abbreviation for undefined. Irrational is undefined if the denominator equals 0. Equals 0, because we're not allowed to divide by 0. Okay, so if that's true, what we're trying to find here is we're trying to find the values of x that make the denominator equal 0. So what values of x would cause this denominator to equal 0? We have to look in the denominator, and you actually are going to find the solutions for the denominator. So what x value would make x plus 6 equal 0? When we find the solutions, we flip the sign. So x equals -6 would make this one equal 0. And then for the second one, x equals this one, +3 would make that factor equal 0, that denominator factor equal 0. Okay, cool. These are the zeros of the denominator. But here's the thing. We don't want to know the zeros of the denominator. We want to know what x values will make this function undefined. It's anything in the denominator that would make the denominator equal 0. So that happens to be the answer. These x values make the denominator undefined. The denominator of that rational function h of x. If we were to plug in x equals -6, this would turn into 0, and it would make the denominator equal 0, because we would get 0 times x minus 3, and then the whole denominator would equal 0. If we were to plug in x equals 3, this would equal 0, which would then cause the whole denominator to equal 0. Okay, let's move on to the same type of question, but worded differently. So which values, here, make sure you write this down in your notes, which values are excluded from the domain, of each function below? We only have one function, so write down the function here. Okay, excluded, we broke this down earlier. Excluded means not allowed. And then the domain is all the x values. Not allowed, the domain is x values. So we are trying to find the x values that are not allowed. That's all we're trying to find. Well, in a rational function, like the rational function that we have here, the only x values that are not allowed are the ones that make the denominator equal 0. So let's write that down. X values that make the denominator equal 0. Those are not allowed. So how do we find what makes this denominator equal 0? It's in standard form now, so what do I need to do? What should I do to find the zeros of that denominator? I need a factor. All right, so if I factor, I get f of x equals x plus 1, x plus 6. That stays the same on top, and then I'm factoring the bottom. We get x plus 1, x plus 2. All right, what x values would make the denominator equal 0? X is, in this case, we're saying what's excluded, so we're saying what's not allowed. So we're going to say x is not allowed to equal. That little cross through means not allowed to equal. Right here. X is not allowed to equal. Well, let's find these zeros. For this factor, it would be -1. That would be what x equals, right? So we're going to say x is not allowed to equal -1. And then for this factor, x is not allowed to equal, what would be the solution to that factor in the denominator? -2. So over here, our answer is x is not allowed to equal -1 and -2. For this problem, we wrote it differently. We said x is not allowed to equal because they used excluded. So it was just like the way the question was worded. Okay, so let's move on. Oh, we do have one more example. Good. Okay, y'all try this one. What x values are excluded from the domain? What x values are not allowed for g of x? Go. All right, remember, we're only looking at x values that would break the function, that would make the denominator equal 0. That's not allowed in a rational. So here's our denominator. What x values are not allowed? X is not allowed to equal -3. Flip the sign. -3 would make that denominator equal 0. These are the restricted values. Just x equals -3. Okay, simplifying rationals. This is our last little bit of notes. So really quick, I want you to do this warm-up. Explain why you can cancel the 5s in part A. You can cancel the 5s in part A, but not in part B. So you can't cancel over here in part B. Pay close attention to the operations in each part. Go ahead and explain why you think you can cancel in part A and you can't in part B. Okay, so it says pay close attention to the operations in each part. Well, what is this operation here? That's multiplication. Multiplication is separating the terms or factors. So when you have multiplication separating terms or factors, then you can cancel. You are allowed to cross out terms. When you have addition, so like check out this one, this is addition separating the terms or factors, you are not allowed to cross anything out. When there's addition in the middle, you can't cross out. You just need to simplify by combining, by adding. All right, so let's go ahead and do some practices because we need to be experts at simplifying fractions for this unit. So here we go. We have what operation here in the middle? Subtraction. So are we allowed to cross out? No, we're only allowed to cross out when we have multiplication. So guess what? This is actually fully simplified. 5 over x minus 5. That's as like simplified as we can get it. We can't cancel anything. We cannot cross out the 5s. Part B, go ahead and write all of these examples down. You need all these examples. All right, here, what operation is in between the 5 and the x minus 5? We have multiplication. That was what we said is good to go for crossing out, for canceling out factors. So we're allowed to cross out those 5s. And if we simplify this, we're going to say equals, what goes on top here? When you cross out everything in the top, what goes on top? A 1. A 1 goes on top when you cross out everything. We crossed out the only thing on top, and that makes the numerator turn into a 1. And then what's left on the denominator? X minus 5. Cool. All right, let's go on to the next one. What do we do here? Subtraction's happening. But can we turn this into multiplication? Let's really quick rewrite this. What is this the same as? X minus 1. Can I factor the bottom? What would the factors be that you get on the bottom? All right, we should use difference of squares. Difference of squares to factor. And we get x minus 1, x plus 1. Well, hold up. Look, we made it multiplication. We made the operation in between these multiplication now. So what are we allowed to do? Okay, this looks like subtraction right here. It looks like we're not allowed to cancel it. But if it matches exactly, if it matches perfectly with something in the bottom, and it is by itself on top, you are allowed to cancel that factor. So we get equals 1 over x plus 1. Because we cross out everything on top, that's why we have a 1 on top. All right, and our last one, are we allowed to cancel anything for this one based on the operation that you see? Can you cross out anything? If so, what? We cannot cross out here because we have addition. So is it possible to simplify? Can we add x plus 2? No. So it's fully simplified. That is what it is. You're done. We can't simplify any further. Okay, let's go ahead and move on to put everything we learned together. Everything we learned for today, let's put it all together. All right, I want you to write down what I highlight. So simplify, and then write down this rational equation. And then which values of y make the expression undefined? Write that down. Everything I highlighted, you need to write down in your notes. All right, and the first thing we're going to do is simplify. Well, let's take this over here really quick. Can we simplify this right now? Can we cross anything out? No, everything's being separated by addition or subtraction, right? But can we factor? Can we factor? Yes, we can. So first, you're going to factor. Factor all parts. Sweet. So now that we know that, let's go ahead and factor the numerator. We have, you could use the box, but I'm not going to use the box just to save time. Actually, I'll show you how to use the box. I'll remind y'all. Okay, so let's go ahead and factor using the box. I'm going to factor the numerator. We need to multiply to negative 34. We need to add to 15. And the way that we think about this are, what are things that can multiply to 34? That's like the first thing I'm going to think of. And then we'll go from there. Okay, so what are things that can multiply to 34? Well, we have 1 and 34, 2 and 17. Oh, hold up. Can these add to 15? Yes, they can. And we need to multiply to negative 34 actually. So how would these add to positive 15 if I make that 2 negative? Sweet. So we have negative 2x. We're going to put these things in, these things in the corner of our box. The corners of our boxes. We have 17x and throw x on them. And then let's put y. I'm putting x, y'all, but our variable is y. So we have y squared. I'm just going to change the x's to y's. And then minus 34 goes here. Cool. Now GCF. We take out a GCF here. We have y. Take out a GCF here. 17 goes into both of those. Take out a GCF on this column. We have y. Take out a GCF on this column. We have negative 2. So our factors are, let's bring it up here, y minus 2, and then y plus 17. And now we're going to factor the denominator. We need to factor all parts, so let's factor the denominator. We're going to use a GCF. So what is the GCF on the denominator? The GCF on the denominator is 3. And then we get y squared minus 4. Are we done factoring? Can we factor the denominator anymore? Can we factor this anymore? Yes, we can, using difference of squares. So equals y minus 2, y plus 17. And we get 3 stays, y minus 2, y plus 2. Okay, sweet. This told us to simplify the rational expression. So that means we need to cross out things that we're allowed to cross out. So what are we allowed to cross out? What is matching in the numerator and denominator and is being separated by multiplication? All these are separated by multiplication, all these factors. So we're going to cross out matching things. Boom. Equals, here's the simplified form, y plus 17 on top over 3 y plus 2 on bottom. All right, we have finished simplifying. We did that in blue. Now let's write the restricted values. What values of y make this expression undefined? Well, that just means what is y not allowed to equal? Y is not allowed to equal. Look in your denominator. What y value would make this factor turn into 0? Well, that's just flip the sign. Y is not allowed to equal negative 2. Here is your answer. Your entire answer to this problem. All right. And that is that, y'all. Good work today.